Okay, the first problem, minus m over 2 is less than negative 2. Okay, you can see that the m is being divided by 2, but it also has a minus sign in front of it. So this is the same thing as minus 1/2 m is less than negative 2. I just rewrote it in a different way. Now, the next thing I'm going to do is I'm going to say, well, gee, I can get rid of that minus 1/2 if I multiply it by a negative 2, right? That changes it to a positive 1, because the reciprocal of minus 1/2 is negative 2. So if I multiply both sides by negative 2, okay, now I've gotten rid of it, and this side just becomes m, but now, because I multiplied by a negative, I have to flip my inequality sign, and 4. So m is greater than 4. And so that was letter B. Number 2. 3 times the quantity n minus 1 is greater than 5n plus 7. Okay, now the first thing you have to do here is distribute. So you're going to do your distributive property to get rid of that. So you have 3n minus 3 is greater than 5n plus 7. I don't have to flip the sign because I didn't multiply or divide by a negative number. Okay? So what I want to do is I want to get all my n's on one side and all my numbers on the other side. And I've told you before, I want to get my n's on the left side just because that's what I like to do. So I'm going to subtract 5n from both sides. This gives me a minus 2n over here, and I just have my 7 over here. Okay? Now, next step. I'm going to add 3 to both sides. That gives me 10 over here, minus 2n. And now, I can finally divide by a negative 2 on both sides, and because I'm dividing by a negative 2, this becomes n. Now I have to flip the sign the other way, point it the other way, and 10 divided by negative 2 is negative 5. So n is less than negative 5, and that's answer D. Okay? Now if I could get this thing to scroll up further, but I might have to just scroll across. Let's just delete some things. Well, we'll just go on. Let's go on to number 3. Minus, okay, now here we have a what? Is that a conjunction or a disjunction? Right here. Conjunction. Why is that? Hmm?
There's no or.
There's no or. And we have a compound statement, don't we? So how you read this is you start in the center with 4c plus 5, and then you read the left side is greater than, because even though that's a less than sign, you want to read this as 4c plus 5 is greater than negative 3 and less than or equal to 1. Okay, so that divides into 2 things. Now some people I've noticed were doing some other things, which, let me erase some of this other stuff, and we'll have some room here to do this problem. I don't know how to grab it, but anyway. Okay, so you can minus 3, 4c plus 5. Okay, some people I noticed were doing this, and you can do this, you just have to be very careful. The reason I separate these two into 2 pieces, I noticed on some of the papers that you were actually doing something to all three sides all at once. Now you can do that, but you want to be very careful when you do that. So that's why I split these up into two equations. Notice you're going to go, this side is going to be solved over here, okay? And this side is going to be solved over here. Be careful when you split those up. So we have minus 3 is less than 4c plus 5. Now notice I could read it as a less than sign now because I'm reading it left to right and I only have one inequality symbol in there. Okay, so I'm solving this side. Okay, I can subtract 5 from both sides, get minus 8, divide by positive 4. Now I just did something that I normally don't do, right? If I divide this by 4, I get negative 2. C is greater than negative 2, but just because this has, I've taught you to read these signs, is less than, you could read this negative 2 is less than C. If I want to flip this, remember the inequality signs are not symmetric. So if you want to flip this whole thing like you would an equality, you would have to put the C on the left, but you have to also flip this sign and point it the other way. Because those two things mean the same thing. Okay? Now on this side, you have 4c plus 5 is less than or equal to 1. You can subtract the 5 over here and you get minus 4, which didn't cause me to flip the sign. And you can divide by a positive 4, getting c is less than negative 1. Okay? So now I have these two things, and what they've asked us to do is c is here. I have negative 2, and I have negative 1. So if I want to write this back as a conjunction like this, I'm going to write the lesser one on the far left-hand side. So I have three things. I have my variable in the middle, c. On the far left-hand side over here, I'm going to write the minus 2. So I write the minus 2 over here, and I write the minus 1 over here, because that's the order things go. Because c is less than or equal to minus 1, so I write the less than or equal to here. And c is greater than negative 2, so I write this one here. And that's how you do those, okay, to put it back. All right? Now, next one. Graph the solution set of the following disjunction. Well, now all of a sudden I know that this is a disjunction. So what I'm going to do is I'm going to look at my graphs and say, which one of these could I eliminate that doesn't look like a disjunction? Does anybody have a clue? Which ones look like disjunctions? These look like disjunctions down here, don't they? Doesn't that mean or? What does this one really say? If I wanted to use X or W, as the case is in here, right here, if I want to use W on over here on this one, how would I really write this W? I would have to say W is what? W is less than or equal to negative 2, or W is greater than 1. Wouldn't that be what the graph of C is? Okay, so what you're really finding is by looking at these graphs, I can eliminate a couple of them, because if I had to look at B or A, I'm looking at probably a conjunction, right? Because it's saying and, it's here and here. So let's take a look at what we can really figure out from these. Okay? Come on, catch up with me here. I know I should just grab them and get rid of them. But then I have to open the menu. Okay. So, let's take a look at 4 minus W is less than or equal to 3. If I were going to solve this one, I would subtract 4 from both sides and multiply both sides by a -1, or divide by -1, either way. And that means I have to flip this sign, right? It goes the other way. And that becomes a +1. So W is greater than or equal to 1. So sometimes when they give you the graphs on these multiple choice, if it's greater than or equal to 1, if that's one of my sides, I can instantly already say that I got a feeling that it's D. Doesn't that make sense? Because this right here is the graph of that. So basically I can say D is my answer for this one, and I've already eliminated A and B because I know they're conjunctions. Okay? All right. Now let's go on to the next page. And number 5, okay, we got a word problem. At the video store you can rent tapes for $1.50 each per day, or you can get unlimited rentals for a monthly fee of $20. Okay, we want to figure out what's the best deal. In other words, if you watch more than a certain number of videos, you're certainly going to spend more than $20, don't you think? If you have to pay $1.50 a piece. So, let's solve this. Let's let X equal the number of videos rented per month. Now that I've defined my variable, I can say, well, if I rent X videos in a month and they cost $1.50 a day, right? That's going to be my total cost for all those videos, right? In 1 month. I want that total cost to be what? I want it to be less than or equal to the fee of $20 for 1 month. Okay? Because I don't want to spend more than the $20. If I spend more than the $20, it's not a good deal. All right? Now, how many can I buy? If you multiply through by 100, and so then divide by a positive 150, okay? How many times does 150 go into 500? 13. 13 point something, okay? So X must be less than 13 point something. Well, you can't, I'm not going to worry about the rest of the decimal because, why? I can't rent a partial video, right? It's got to be a whole number, okay? So what we're talking about is I can rent up to 13 videos and still be less than my $20. Okay? So B. Okay, number 6, the absolute value. Now absolute values work a little differently. Remember, whatever's inside that absolute value in here can be positive or negative. Because once I take the absolute value of it, okay, I've got a number without the sign. So, to solve that one, let me just delete this stuff. Maybe we'll just do, whoa, I want to delete that. Yeah, we're just figuring out how to use this thing. Some of them I'm just going to, doesn't work. Okay, I got enough off the board. We're not going to worry about the rest. Number 6, the absolute value of 5 minus x over 3 is equal to 7, which means that if what's inside the absolute value sign can either be positive 7 or negative 7 to make this true. Some of you are forgetting. Okay, when I look at your homework, I'm seeing you just take the absolute value signs away and throw them away. You can't do that. Okay? You can do that for half the problem. You're only halfway done. Okay? So you're only getting half credit on that. Remember, this in here, 5 minus x over 3, is either equal to positive 7 or 5 minus x over 3 is equal to minus 7, negative 7. So now you have to solve both of these as a disjunction. So subtract 5 from both sides over here. This is the same as minus 1/3 times x. So I'm going to multiply by a negative 3, both sides, to get rid of it. And then I just end up with x is equal to, and I don't have an inequality sign, so I don't have to flip anything, minus 6. Or, over here, same thing, subtract 5 from both sides. And what do I get? Minus x over 3 is equal to minus 12. Multiply both sides by negative 3. I don't have enough room over here to write it if I don't move over a little bit. Okay? Once I do this, I just have x is equal to positive 12 times 3 is 36. So x is equal to 36 or negative 6. Some of you were only getting one answer. Be careful. I don't want you to just get one answer on your test tomorrow because, okay? Oh, it's negative 6. Oops, sorry. Negative 6 or 36. Negative 6 positive 36 was A. Sorry, I selected the wrong one. Okay, now, I'm going to go back over here. The last one, again, the absolute value of 2y minus 13. Or plus 9 is less than, let me get this thing up so I can grab this and get rid of it. Okay. Only problem down here. Okay, is less than 13. Here, 2y plus 9 is either less than a positive 13, just exactly, write it exactly like it is, and this is another case, okay? It's absolute value. So if I change the 13 to a minus 13, I've got to flip the sign. So this is a disjunction also, or 2y plus 9 is greater than negative 13. Okay? I know this gets a little confusing with all this stuff on here. So let's get rid of some of it. Wish you could grab it all.
Grab the arrows in the corner.
Oh,
Yeah,
these
it doesn't
things?
spread them out yet. Oh,
They just make it bigger.
My bad.
Oh, it just takes me a minute to delete them all if I have to keep.
Megan, what was that? Megan,
There, we're all cleaned up.
Claire, easy girl. Okay.
Corny throwing those very unacceptable.
Claire.
Early one.
Claire.
Oh, fine, this is not hit me in the face. Oh, stop it.
You girls are mean.
There.
That just happened.
We'll just forget I wrote that or right there. Alright, now I'm ready to solve
Can
two
you
different
please get rid
things.
of that dot right there because it's really been bothering me.
Yeah, the one
That
from
dot?
13.
Above the 13.
Oh my goodness.
There you go.
Make it really big.
Delete.
Okay.
Just make it like a big block.
do it, you have the numbers.
I know, but I'm trying to get rid of all this stuff that's in the way. All right, now I'm ready. Okay, let's write 2y plus 9. There, now we've got it set up, right? Because if we have 2y plus 9, it can be either, if that were an equal sign instead of a less than sign, I could have set it up as equal to positive 13 or equal to negative 13. But when I change that sign to minus 13, then I have to go. I'll just get rid of this thing. Okay, then I have to flip this sign. So solving the left side over here, just the normal one, subtract 9 from both sides, divide by a positive 2, or, so no or. Over here, subtract 9 from both sides, and I'm actually adding it to the negative 13, right? So 22 minus 22 and 2y, and I'm going to divide by 2. Now, I don't have to flip the sign here, remember, because all I did was subtract 9. I didn't multiply or divide by a negative number. So I divide by 2, y is greater than minus 11, okay? So now my answer's up there. Y is less than 2, which means y is less than 2 or greater than negative 11. And I think that I erased one by accident. Was it C? Yeah. Yeah. Less than negative, or y is, oh wait a minute, nope, here it is, it's D. Sorry, it's D.
What?
Y is less, no wait a minute, it says it's greater than negative 11.
It's definitely.
Okay, it's C, because I can't see C. Alright, so it's C. Sorry.
Miss Courtney, when you're in mom foot
Okay, number 8. The absolute value of 4 minus h greater than or equal to 5. Guys, come on. Come on. Okay. This means that 4 minus h is what? Greater than or equal to 5, or 4 minus h is less than or equal to negative 5. Okay? Okay, over here, subtract 4 from both sides and multiply by negative 1 to get rid of the negative sign, which means I flip the sign. And I multiply both sides by negative 1. Okay? Over here, 4 minus h, subtract 4, I get minus 9 over here. Multiply by negative 1 flips the sign again. So I have h is less than or equal to negative 1, or h is greater than or equal to 9, and that's letter A. Okay? Describe the graph of the solution set of the absolute value of k. Now be careful here because they're saying describe this. Okay? Remember our difference? Change this to a difference. If this were a difference, what would I have? The distance from where? Where am I going to start, Jared?
3.
No, I'm not.
Negative 3.
The distance from negative 3, what? Is less than 2. This is what they mean when they say describe the absolute value, that inequality, the solution set. Okay? So in other words, they have, if I have start at negative 3, and I know that that's from negative 3, and just because my words are different, the only things that involve from negative 3, okay, are these two, B and D. And it's less than 2 units from there. So less than 2 units, points less than 2 units from negative 3. Okay, at most means it's going to be before 2 units. It'll be in between there and 2 units. This is, okay? Oh, wait a minute, at less than 2 units. Points less than 2 units from -3. That's correct. Okay. A theorem that can be easily proved from another theorem is a what? You can't prove a theorem from another theorem. Corollary. Okay? Or a property. Which one do you think it is?
B.
You think it's a corollary?
Yeah.
A corollary is not a theorem, though, is it? Think about it. What'd you learn in geometry? A corollary was what? A statement that can easily be proved from a theorem, right? That's what a corollary is. Is that a theorem? There were differences, weren't there? Right, Sam? Differences. So really what we're talking about is we said that we could make them the properties. Remember our properties of order? So the right answer here is property. Because the properties can be derived, and we can call them new theorems because they're derived from a theorem. Okay, the converse of true statement is a corollary, never true, always true, sometimes true. Come on, you know this. Maggie?
Wait.
Sometimes true.
Proving theorems, like, there's a line that says a theorem that can be proved easily from another is called a corollary. Is that
Okay, so corollary. Let's call it a corollary. See, they also said that we could call these properties too. When we derive something from another, we could call that. So, okay, corollary. We'll accept corollary for that one. Okay. In the geometry book, they said that a corollary was a statement that was easily proved from a theorem. Okay, what, Jared? What?
English. I thought it was corollary.
It is corollary.
But you said property.
I know.
So which one is it?
It's corollary.
No,
According
you
to
said
this,
I got it wrong.
according to this book, it's the corollary. Okay, I'm sorry, but the
No, it
geometry
wasn't
book
your fault.
calls
It was Crystal. It was Crystal.
the geometry book. That's why it's confusing because the geometry book called the corollary something different. Okay.
Geometry, isn't it?
No, I know, but we still have to use it. So, Jared, you're right. Sometimes the converse is true, not always. Remember, sometimes. And what happens if it's true? What do we call it? You remember? What is it if it's all if the converse and the statement are both true? It's a biconditional, right?
Who doesn't know that kind of stuff?
Yeah, who doesn't know that kind of stuff? Okay, let's go. Now, supply the conclusion that makes each statement true. For real numbers AB is equal to 0 if and only if. This is your what? Zero product rule, isn't it? Zero product rule. Yeah, it was the next page. You had to flip the page to get to the rest of them. Okay? So, that means A is equal to 0, or B is equal to 0, or both are equal to 0. Okay? A equals 0 or B equals 0. They don't have to both be 0. The and says they both have to be 0 by the rules of logic. This says one or the other. If I have one or the other, that makes it true. Okay? I don't know what, I can't use A or B because that doesn't necessarily mean that B itself is equal to 0 because A could be equal to 0. Okay? And B doesn't have to be. Okay, so that's C. For real numbers A, B, and C, if A is greater than 0 and C is less than, what does this really say? If A is greater than B and C is less than 0, what have I told you that means? C is what? Negative. C is negative. Okay? Then, okay, if A is greater than B, okay, is this true? If I divide both sides by C, and C is negative, okay? If C is negative and I take this one and I divide both sides by a negative number, don't I have to flip this sign? So that one cannot be true, okay? if C is negative, okay, and A is greater than B, and I multiply both sides of the sign by a negative number, that can't be true, can it? Because I would have had to flip this sign. Okay? So now over here, AB, this one is true. Okay? Adding a negative to both sides doesn't flip the sign, which is why this one cannot be true. Okay? All right, so that's all of the chapter review.
Do we hand this in?
You can if you want to, or if you want to keep it for your notes, you may do that.